In this video, we're going to be learning about the derivative, and we're finally going to learn one of the shortcuts that we can use to calculate the derivative of the function, and that is the power rule. But before we get to that technique, I wanted to go over notation a little bit, because there is some notation that you're going to want to make sure you're familiar with when it comes to the derivative. And so in the formal definition of the derivative video, we talked a little bit about the notation. We said that if we had some function y and we wanted to talk about the derivative of y, we would use the notation y prime. So putting this little tick mark, this little apostrophe here, is read prime, and that means that this y prime is the derivative of y. And we can do a similar thing if we're using function notation. So if I have some function f of x and I want to talk about the derivative of f of x, I also put a little tick mark right there. So this would be read f prime of x. And again, if I had some function g of x and I wanted to talk about the derivative of it, I would say g prime of x. And that prime is denoted by that little tick mark. So if we want to find the derivative of something, this is how we are going to notate it. And there is also a second derivative, which we will talk about more in depth in future videos, but what that means is that we're taking the derivative 2 times. And the notation for that, if I had some function y, and I wanted to know the notation to represent the second derivative of y, I would do 2 tick marks. So these 2 tick marks mean the second derivative of y. And the same thing with function notation. If I wanted to talk about the second derivative of f of x, I would put 2 tick marks there. And so that is a notation for when you're taking the derivative of functions. This is how we notate it. So now we're going to talk about the power rule, which is a way that we can actually calculate the derivative of a function. In the definition of the derivative video, we talked about how if we want to find the slope of a function, we want to find the slope of its tangent line, but how do we actually go about doing that? And so the power rule is one kind of technique or shortcut that we can use to find the derivative of a function. So if I was given some function, we'll do y equals x squared, and I wanted to find the derivative of this. I wanted to find y prime, or dy dx. Power rule says that we take whatever number's in the exponent and we put that out front. So I took the 2 that was in the exponent, I put it out front, and then whatever the old exponent was, I subtract 1 from it. So I subtract 1 from 2, and that becomes 1. And x to the first power is just x. So y prime is equal to 2x. So this is the power rule. It's that simple. We just take whatever the exponent is, put it out front, and then subtract 1 from the old exponent. And this is your y prime. This is your derivative function. So what this means is if I wanted to know what the slope of my y was, what the slope of x squared was at the point x equals 4. I wanted to know what the slope of this parabola was when x was 4. All I have to do is plug 4 into my derivative function, because my derivative function tells me what slope is. You input an x value and your derivative, your y prime, outputs a slope. So if I plugged 4 into this function, 2 times 4 would be 8. So that means the slope of this parabola of x squared at an x value of 4 is 8. So another way to say that is the slope of the tangent line would be 8. So if we were to draw that, I have my parabola x squared here, and we'll say that 4 is right there. So if I were to draw a tangent line, a line that is tangent to this parabola at x equals 4, the slope of this line is going to be 8. And we calculated that by finding the derivative function and then plugging in the appropriate x value. So this is all the power rule does. It's just if you have some sort of power function like this, it gives you a really quick, easy way to calculate the derivative function. And then the derivative function lets you plug in any x value you want to calculate slope. So we'll do a few more examples to really help solidify this. So if I had some function y equal x to the 20, and I wanted to calculate the derivative of this, or y prime, what I would do again is take whatever exponent is up here and put that out front, and then subtract 1 from my exponent. So 20 minus 1 would be 19. And that is my derivative function. This is my y prime. So I can plug in any x value and it'll tell me what the slope of the tangent line to my original function is going to be. Another example is if we had, we'll say y equals x to the negative fifth. So I get a lot of questions, well, what happens if that exponent is negative? Is it a different process, or how do we apply power rule? And the answer is that it's the exact same thing. It doesn't matter what your exponent is, power rule is always going to work the same way. So if this is my y, and I wanted to find y prime, again, whatever my exponent is, I would put that out front. So the negative 5 is going to go out front. And then I'm going to subtract 1 from my exponent. Now be really careful here. We're subtracting 1 from a negative number. So we're taking negative 5 and we're subtracting 1. So that's going to turn into negative 6, right? Negative 5 minus 1 is negative 6. This is a really common mistake made with the power rule that I see students make when the exponent is negative, is they end up adding 1. They try to say that that's negative 4. So remember, if we have negative 5, we're subtracting 1, that's going to turn into negative 6. What if we had y equals x to the 2/3? What happens when our exponent is some fraction? And again, it's going to be the exact same process for y prime. We're going to take the exponent, we're going to put it out front. So 2/3 is going to go out front, and then we're going to subtract 1 from the exponent. 2/3 minus 1 is going to be negative 1/3. This is another common mistake I see made, is when there's a fraction exponent and people are subtracting 1, they just do the subtraction wrong. So make sure that if you're subtracting 1 from a fraction that you feel confident on that math. There are some unique situations that are worth looking at. And so one of them is if we had y equals x to just the first power, and we wanted to take the derivative of this. We wanted to find y prime. So again, we're going to follow that same rule for power rule. Power rule says take whatever exponent is up here and put it out front. So that 1's going to go out front. And then subtract 1 from the exponent. And 1 minus 1 is going to be 0. So we have y prime equals 1x to the 0. But what is any number to the 0th power? That's something that you want to make sure you know. Any number raised to the 0 power is always 1. So x to the 0 power is going to be 1. So y prime is going to end up being 1 times 1. And 1 times 1 is just 1. So in this case, our derivative is just 1. And what does 1 look like? Well, 1 is just a straight horizontal line at a y value of 1. So that means if you take the derivative of this function of y equals x to the first power, the slope of this function is always gonna be 1. It's always gonna be whatever the y values of our derivative are. And that makes sense, right? Because y equals x is a straight line that goes through the origin. And we know that linear functions have the same slope everywhere. So it makes sense that when we take the derivative of this, when we calculate the slope, it's always just the same number. It doesn't change. There's no x term here. So that's a situation that sometimes kind of trips people up because they're not sure if it's possible or if it's okay to get just a number out for your derivative to have no x. And yeah, that's perfectly fine. That means if you get just a constant number, that means your slope of your original function doesn't change. It's the same slope everywhere. One last example I want to look at is if we had y equals x to the 0th power, and we wanted to find the derivative of this. So again, using power rule, if we want to find y prime, we're going to take the exponent, put it out front, so we're going to have 0, and then we're going to subtract 1 from the exponent. So 0 minus 1 is going to be negative 1. And so here we have 0 times x to the negative 1, and we know that any number times 0, anything times 0 is just going to be 0. So this is going to simplify to just 0. So that means that this function here has a slope of 0 everywhere, all the time. And a slope of 0 means that it's just flat. It doesn't have any steepness to it. And that makes sense because what is this function, y equals x to the 0th power? What does this function look like? Well, any number to the 0th power is just 1. So this function right here is actually just a straight horizontal line. and we calculated that the slope of it should be 0. And that is true. Any flat horizontal line is always going to have a slope of 0, because slope means steepness, and if it's perfectly flat, then it has no steepness to it. So this calculation that the derivative is always 0 makes sense with what this function looks like. So hopefully that gives you a nice idea of how to use the power rule, and as with anything, this is going to get more complicated as you go on in AP Calc. We'll add more rules and stuff, but power rule is probably the one that you'll use most often, so make sure that you're really comfortable with it and you're okay with the notation and you know how to kind of make sense of whatever you calculate as the derivative and your picture. Those two, the algebra and the picture, should always line up. They should always match each other. So it's good to try to connect the two as much as you can. As always, if you have any suggestions, improvements, concepts you want to see, make sure you leave those in the comments below, and don't forget to subscribe.